Our last review topic in this section is graphing transformations. So I know we talked a lot about this in pre-calculus, but this is another thing that's just really important to remember, that we know how to graph transformations. I'll give you a foldable that you can glue into your notebook. So if you want to refer to that, that'll help. Also, in your textbook, there's a great resource talking about what the different transformations means. What the transformations do, excuse me. So first off, we'll look at the parent functions. We know we have a few more parent functions that we talked about before with like sine and cosine. And then there's a new parent function that we didn't really talk about much in pre-calculus, but it's not that bad. Just remember this one, x to the 2/3. Looks like this. It's kind of like a mix between x squared, the cube root of x, which is like this little squiggly thing. But then we square it, so we take everything that was negative and we just pop it up to be positive, kind of ish. That it's just the way to remember it, right? So we've got the line, parabola, x cubed. Remember, this is an odd function, so that should give us that. X to the 4th looks a lot like x squared. It's an even function, but it's just a little flatter. And you'll notice as you get higher and higher order on degree on your function, you're going to have flatter and flatter ones. Square root of x, remember it's just the top half of a sideways parabola, because if we had y squared equals x, let me write this for you. If we had y squared equals x, and we solve that for x, we would get y equals positive square root of x and y equals negative square root of x. Those are the two things we would get out of that, right? Because we get plus or minus. And so the positive square root of x is just the top half of that parabola, and then the negative square root of x would have been the bottom half of the parabola. So y equals square root of x is just the top half of a sideways parabola. Y equals cube root of x is just x cubed on its side, really. It's just the inverse. So we switch all the x and y's. It's because it's the inverse. Y equals x to the 2/3 we talked about. Absolute value, I don't know how much we hammered this one, but basically think about this is a line, right? This is just a line. Set the line y equals x. But then when we take the absolute value, we take all of the x values that are less than 0, right? All of the negative x values can no longer exist, right? But we can put them in, and when I put in -1 to this, I get out the same thing as if I put in +1, right? So all of this down here can't exist anymore. Only this up here can exist, because only positive values can, not that they can't exist, they'll just come out the same, right? If I put in +1 into this function, it comes out the same as if I didn't have the absolute values. But if I put in -1, it's going to come out the same as +1. So it just reflects across the y-axis there. So anytime you take the absolute value of something, what it does is it erases all of the values you had for negative outputs, and it just copies and pastes all of the values you had for positives, right? So it says, hey, none of these ones down here can exist anymore because we can't put in negative values and get out, we can't get out what we got in before when we put in negative values. But when we put in negative values now, we're going to get out the same thing as when we put in positive values. So you'll see that some more in transformations. Here's some more of our parent functions. 1/x is just like that. And then this one, 1/x squared, remember, basically it just takes everything. Again, it makes all of these values positive, so we're going to come up here. So I would, and then we've got our circle. I would, if I were you, I would memorize these. Like, don't tattoo them on your arm or anything, but like put them up by your bed, and when you can't sleep at night, look at them and memorize them and think about them. Make them your home screen, your lock screen. No more boyfriends on your lock screens. You need parent functions, okay? Okay, I don't care. But you know what I mean? You gotta memorize these, because what happens is when you see something like in our last video, we saw something that was like 1/x minus 2. You need to know what that graph looks like, right? And if you can recognize, oh, that's just the parent function with a little transformation on the x's, that's so great. If you don't recognize that, you're going to cry a lot. So I would just memorize these a lot, Okay, so all of our graphing adjustments are here. Let's just go over them really quickly. Again, no, I don't want to do that. My rule of thumb is always, is it inside of the function or is it outside the function? Meaning, is it with the x or outside of the x, right? So in this case, this one is outside the function, right? Because whatever's happening to the x is not happening to this negative sign, right? This is like if I had y equals x squared, and I just did y equals negative x squared. I'm not squaring that negative, right? Right? That would be y equals negative x squared. Do you see the difference in this? This value, this negative sign is not doing the same thing as the x, right? The x is getting squared. Is the negative sign getting squared? No, it is sure not. In this case, the x is getting squared, and so is the negative sign. This is outside the function. This is inside the function, okay? If something is outside the function, then it changes something on the y's. If it's inside the function, it changes something on the x's, okay? So if this negative sign is outside the function, it reflects over the x-axis. In other words, it takes all of our y values, and it changes their sign, right? So if they were negative, they're now positive. If they were positive, they're now negative. And then if it's inside the function, this is going to change all of our x values, right? If they were positive, they're now negative. If they were negative, they're now positive, okay? These ones are easy. These ones are just a shift. This one is outside the function. Remember H and K, in this book they call them C and D. I don't like that. It's really H and K in a lot of other places, but that's okay. So this one is outside the function. So it's going to shift it left and right? It's going to add numbers to the y or subtract numbers from the y. And remember, y is not a liar, right? Sorry, I did that by the x. Oh my gosh, these are y's. Ha! These are y's, these are x's. So it's going to shift it up and down. So y is not a liar. So if it says positive 3, we go up 3. If it says negative 3, we go down 3, right? If it's inside the function like this, if it happens with the x, it's inside the function, then it's going to shift it left and right. It's going to change our x values, so that's going to go either, further to the left or further to the right. Now remember, x is a liar. Your x is a liar. So if it looks like it says positive 5, instead of going positive, we go negative. Okay, and if it looks like if it says x minus 5, we go positive, okay, because x is a liar. Now, if we have something out here, we vertically stretch it, which means that, again, this is outside the function, so it's going to do everything to the y values. And so if you have it outside the function, you basically just multiply all your y values by that number, okay? So for number 5, you just multiply all your y values by that number, because y is not a liar, right? It's being multiplied. It does exactly what it looks like. Now for number 6, though, this is inside the function with the x. This one is a liar, right? So you're thinking, oh, I just take all my x values and I multiply them by that number. But no, because x lies. So instead of multiplying everything by that number, you're going to divide all your x's by that number, okay? It's going to stretch or compress. And really, you just have to memorize this one. This one is really challenging to remember a lot of times, and people just get really tripped up on this b value. Just divide all of your x values by that number. So take whatever you would normally have, divide it, okay? If the absolute value is outside your function, then it just changes all your y values to be positive. So the function still functions inside, right? Everything happens inside, and you get an output, right? But when you get that output, you don't get anything negative, right? If you get a negative output, it just changes it to positive. So if you had anything below the y-axis, below the x-axis, so if you have anything like down here, right? If you have any of these values, they just become positive. So the output comes out the same. It's just a positive number instead of a negative number. So you have something that looks more like that. Okay, now finally for the other one, this one is that absolute value that's just a little bit challenging to think about. But again, the idea is if you have this function, and it has to be like an odd function for it to work. So if you have this function, it says, hey, all of these x's, these negative values, these outputs don't exist anymore because we can't put those negative values, or when we put those negative values in, they don't give us the same outputs anymore. When we put those negative values in, they come out the same as if we put the positive value in. So it just reflects across the y-axis. Okay, so lots and lots of little like things, but let's practice. So here we have just a random function. We use this one because it's just really easy to see asymmetry and everything like that. Okay, so the first one is, I sketched the first ones just for sake of time. The first one we said we took the, inside the function we added 2, right? So x is a liar, so that means instead of adding 2 to our x's, we're going to subtract 2 from all of our x's. So this point right here just moves to the left 2, 1, 2, and it becomes right there, right? And that's it. And so we just move all of our points to the left 2, and then we're done. And then this one, it looks like we have, let's see, so we, outside the function, we have a reflection. So that means we take all of our y values and we reflect them across the x-axis, right? So this point right here, actually this point doesn't reflect across the x-axis because it's on the x-axis. This point right here reflects, right? So instead of being positive, it now becomes negative. This one comes down here and this one goes up there. So that's what this orange one is first. And then, so we do multiplication first and then we do addition just like in any other order of operations. If we're doing it outside the function like this, then we move it up 2, right? And y is not a liar, so we move it up 2. Okay, so then this one, let's do everything inside the function first. Then we're going to do everything outside the function. Okay, so the x, this just said all of our x values just become negative. So instead of being, you know, so this point right here, instead of being right there, goes over here. This point stays right there. And then this point becomes that one right there. So we have this. Oh, I should have done that in yellow, but, or orange. That's okay. So there's that one. That's the first one, right? We reflect it over the y-axis because all the x values just change signs. And then outside the function, I have this 1/2, right? Which means I take all my y values and I multiply them by 1/2. So I multiply all my y values by 1/2. So now this one, instead of 2, becomes 1, and this one becomes 1, and this one becomes 1/2. And so it just squishes it. That one is a 0, so it doesn't matter. So it just squishes it. So the green one is my final on that one. Okay. Now this one, we do everything inside the function first. So we've got this 2 inside the function, which means we divide all of our x values by 2. So I take all my x values and I just divide them by 2. So I'll actually do this right this time. So this one is -2, so it becomes -1. This one was 0, so it stays where it is. This one is 3, so it becomes 1/2, or 1.5, excuse me. And then this one becomes 1/2. Okay, so there's the first thing. That's what I divided by 2 first. Okay, I divided all my x values by 2. Now I do everything outside the function. And what it does is it said all of my output, all of my y's are now positive. Everything that comes out of this function is now positive. So I keep everything that's positive, and then everything that's negative just becomes positive. So it's not great, but there we go. All right, last but not least is this one, and this one is really, this is a tricky one. These ones that are inside the function are very tricky. So remember, it says, hey, all of these values here on the that had negative y's or negative x's can no longer have those outputs because when I put those negative numbers in for x, I'm going to get the same thing out as if I put a positive number in for x. So these ones aren't going to change, right? If I put a positive number in an absolute value, nothing changes. It comes out positive just like it did. So this one stays the same. But then what happens if I put those numbers in negative? What happens if I put -2 in? Well, it should come out the same as if I put +2 in, right? Because it's an absolute value. And what happens if I put -3 in? Well, I'm going to come out with the same value as if I put a +3 in. So I just reflect it over the y-axis. And there you go. Those are transformations in a nutshell.